Hey guys, welcome to the video series of data engineering on Microsoft Azure DP 203. Hope you guys are doing well and staying safe. In today's video, we will be covering Azure Databricks and the topics related of Databricks in DP 203. Databricks itself is a very broad topic, but we will be focusing only on those things which are important or critical for the exam. So without further ado, let's start. Today we will be covering the following topics: what is Azure Databricks, the various components of Azure Databricks, types of cluster, and a sample demo of all these components and the Azure Databricks. So there is some prerequisites if you want to understand the Azure Databricks. That is, you need to have some understanding of the Spark. If you're already aware about it, that's good. Otherwise, please visit my video on Apache Spark. I'll provide the link in the description. So the first questions come into the mind: what is Azure Databricks? Azure Databricks, before jumping into the Azure Databricks, let's try to understand what is Databricks. Databricks is a platform which was formed by the founders of the Spark. It is basically they build infrastructure on top of the Spark engine, so the users don't have to worry about the Spark infrastructure. So if you understand Spark, like in Spark, you need a cluster to run your jobs. The cluster could be single node or it could be multiple nodes. But setting the all Spark configurations and managing, like if it's a big cluster, like more than 100 nodes in it, it's hard to manage. So to solve that problem, the Spark founders bundled all those things into one infrastructure and opened this platform named Azure Databricks. And in simple words, that same platform is hosted in Azure, is known as Azure Databricks. And here we are using Azure VMs as a node. Or if you're gonna want to talk, say it in other words, we can say it it's a data analytics platform optimized for the Microsoft Azure cloud service platforms. And if you want to further simplify, it's basically unified data analytics platform built on the cloud. It's not just Azure. You can find the same thing in AWS too. So it's basically a unified data analytics platform built for the cloud or distributed cloud systems to support various personas of the organizations. The components. So this is important for exam perspective. The components of Databricks are workspace, clusters, notebook, jobs, and data. We'll see all of them in details in the demo, but we'll touch them now too. So workspace, it's very similar to the concepts of the projects, or when you are building a project in let's say, when as a developer you have your own workspace. Similarly, if you come from Linux backgrounds, you create your own workspace where you work in, and so each workspace is kind of isolated from others. And in Azure Databricks, there is an identifier for each workspace, and everything is deployed in some access control manner for that particular workspace. So if you're working for different teams, or we can think from organization perspective, different teams will have different workspace, or different projects can have a different workspace too. Cluster, that is really important because they asked in the case study questions, they ask about a lot about the clusters. For our understanding, we can say it's at most basic level. In Azure Databricks, the cluster is a series of Azure virtual machines that spin up with the Spark configurations and are used together to unlock the processing power of the Spark. Notebooks, this is web-based, pretty much like Jupyter. It's a web-based interface where you can interact with your data, you can write code and all those. So it's a web-based IE, and it's pretty same like a Jupyter notebook. Jobs, which you can create your jobs, which you can run periodically, and data, as we all know, everything related to data. So when I why I mentioned data here, Azure Azure Databricks can connect to various components of Azure but they have their own file system too. They call it Azure Databricks file system, which for a user it seems like it's like a mounted file system of Azure Databricks, but at the back end, like it's just a data lake where you're storing everything, and that data lake is mounted. But like for data, they have a file system which come by default mounted to the Azure, or you can say this is like a managed file system with the Azure Databricks. Cluster, if you come from the Spark background, like as soon as you see this picture, you will understand like in cluster we have driver node and worker node. Driver node, which basically like our code or program, which like it's a node where we write our code and program, and it tells the worker nodes what need to be performed or what tasks need to be done. So I just want to give you like what exactly a cluster look like. That's why I added this slide, is just to give you a brief idea. Like it's pretty same as the Spark cluster. Okay. Types of Azure Databricks clusters. So there are mainly two types of clusters. Pool is not like a cluster type, but I'm going to talk about that too. So there are like two types of clusters: all-purpose and a job cluster. So all-purpose cluster is mainly for most of the work, like our day-to-day kind of activities, and it have three different types of modes in it: standard, concurrence, and single. So the single node cluster is basically it's a cluster which consists of driver node but no worker nodes. So there is like only one node which is working as a driver and worker both. There are no other nodes in it. And this is like this started very recently, like in 2021. This is for like light-weighted exploratory analysis or any like single node machine learning kind of activities. Concurrency, as the name says, like this is a cluster where like multiple users can do their jobs and like can work concurrently without impacting each other's. Standard is pretty same as the single node, but it have at least one worker node in it, and it is used for like those kind of activities where like you don't need multiple people to work on something, so you can use standard cluster there. So they're like concurrency. Basically, you need to keep in the mind like in what scenarios which all-purpose cluster you need. So single cluster will be for, as I mentioned, lightweighted or very small kind of task. Concurrence is like when you have, let's say you have a good number of analysts, they're working together, like any job where like multiple users will be working together. For that kind of situations, we go for a concurrency. Standard could be like depending on the use case, but let's say you have a team of 10 people. Out of that, you have only 2 data scientists, so you can have like you can spin up 2 standard clusters for data scientists. And in standard clusters, we will see like we can we can use different runtimes or like more horsepower depending on the use case. For like, for example, for if data scientists are doing deep learning or something, so we can spin up like GPU nodes in it. Job cluster is basically it's a cluster which spin up automatically to do certain tasks and terminates when the job ends. It's isolated, like it's not dependent on anything else. It can't be rerun. Like once it start and terminated, like you can't rerun it. And it's good for those production jobs where you like it's for those data pipelines or those jobs which are like finalized and productionized, or like are in production. There you can use the job cluster. They will come, run the pipeline, and the cluster will die. So in this way, like you are saving, like it's a cost saving approach too. Instead of like running the cluster throughout the day, like you just running the cluster when you need for your job. Pool, that's another thing I want to talk about. It's not type of the cluster as I mentioned initially, but it helps clusters associated with it reducing their cluster start and auto scaling time. By like in Pool, they already maintain a set of idle ready to use instances. So if job clusters can't be associated with pool, like all purpose cluster, let's say concurrency cluster is associated with a pool, and like you set the cluster on auto scaling, and we're going to see in the demo how to do it. But like, let's say you are you have a concurrency cluster where you set your cluster on auto scaling and all your resources are consuming everything. Then to increase the nodes, like it will take some time to spin up the cluster, like spin up those nodes, and like starting those nodes will take time. So this, like if you're like this, if our concurrency cluster is associated with pool, there will be some idle instances or nodes will be there which will be available right away. So it will help to save time. And and there could be a situation when pool don't have any idle instance. So for example, if your pool have, let's say, two idle instances and they both were used, in that case, like pool expand like its instances by allocating new instances or new nodes. It works pretty same as like a regular pool concept, where like, let's say a cluster like takes an instance or release an instance. Like if takes an instance, like it will reduce from the pool, but if they release an instance, it will return to the pool and will be available for the other clusters to use. And we will see in the demo how we can associate a cluster to the pool. And next slide. So to set up the clusters, there are like four main things which you need to keep in the mind, like which Databricks runtime version you want. So basically there is we have a drop down options from where we can pick which version we want. Same for the node configurations. We have like separate node configurations for the drivers and the worker, along with the numbers of the workers. Auto scaling, which was I was mentioning initially, so we can decide the minimum and max, and we can also, like in auto scaling, as I mentioned, we can associate our cluster to a pool. So in that way, we don't have to wait for the the nodes will be readily available, instead of the cluster is waiting for the new nodes to spin up or the new instance to spin up. And there is a last thing is the auto termination, which is like basically it's a way of saving money. Also, like if your cluster is idle for a certain amount of time, you can like terminate it. Okay, so now let's jump to the one second now. Yeah, let's jump to the demo. Okay, I go here. So for the sake of time, I already created a workspace, but I'll show you everything, and so you get an idea how to do these things. So the first thing is like if we go to our Azure portal, the things like we need to search for Azure Databricks. Like you can type Databricks and this service will pop up. You go there. You can see I already have workspace. So you can create your own workspace. You click on create, and it's very easy. Then you select your resource group, give it a name. Let's say Data Tech Demo 2. And then the reason based on your location, and the pricing tier is like standard and premium is there. So for the people who are like for demo purposes, we will use the standard, but the people in organizations or like who's using Azure Databricks professionally, for them like premium is there. And even if you like wanna give it a shot, like there is a trial version too for it. I'm picking standard. I'm not going to I'll click on review and create, but I'm not going to create it because I already have it. But like once you create on this, you will get something like this, like DataTech DB2 or something, whatever name you give it to the once your workspace is created for the Azure Databricks service, you click on this, and after that you just click on launch workspace. And after like it take just a couple of seconds, and you will land here. So here this is the Azure Databricks, and it's like like if you, even if you like go to, let's say, AWS Databricks or directly to the Databricks, your this space, like the workspace, or you can say it will it will look pretty same. Like there is no difference in it. You will find if you're using AWS Databricks, then also it will look same. And even if you're going directly through the Databricks, and if you want to learn Databricks like a off the topic, there is a like a free version of Databricks community version or something which you can sign up, and you will find pretty same. Instead of Azure Databricks, there you will see Databricks. The components I was talking about. So workspace, data, compute is a cluster, and jobs. So workspace, as I was mentioning to you, the workspace is basically like it's pretty much like, as I was mentioning, like it's a project which is isolated. So you can have like shared projects, or you can have projects which are like not shared. So in that, or like a user specific things too. So if you click on this, like I'm the only user here, but like if you're an organization, you might see multiple, or it could be either way. Like shared is basically it's those shared projects which are like multiple teams are working or something like that. But the idea here is to explain like whatever you do, it stays in your workspace, so it's isolated from others, and until you don't share it, it's like it's with you only. Okay. Repo I didn't mention, but like you can you can add any repository to it, like a GitHub and all those kind of things. We are not going to do that, as we are not focused on like how like more on Databricks. This is more as I mentioned, talking about from DP 203 perspective. Here it comes the clusters. So as I was mentioning initially, there are like two types of cluster. One is the all-purpose, second is the job cluster, and pool, we'll see it later. So all type of cluster, which all-purpose cluster, as we talk, is like used for day-to-day kind of activities. So how we create it, if we click on this, then you give it a name of to the cluster, let's say cluster 2. And these are the mode I was we discussed previously: high concurrency, standard, or single. So high concurrency is for situation where like multiple people are concurrently using the cluster. Standard we talk about at single node, where like there will be no worker, only one node, the driver node will be there. And if you remember on my second last slide, I mentioned there was like to set up a cluster, these are the four main things. So runtime, Databricks runtime. So if you see here, like, so there are like so many like images are already available to us. So based on your requirement, you can pick an image, and this is the Databricks runtime. So these are the standards. Even they have like for machine learning too, which is pretty cool. So you don't have to install anything. Like everything is already packaged for you. Just you select like your runtime based on your requirement, and you're good to go. So that's where like this is very handy. Like you don't have to worry about the infrastructure. We stick to the default version, but this is what like a runtime means. It's like an image already available for you, and you can spin that. And the other two things I mentioned is the auto scaling and enable termination after, so like after certain amount of time in like after certain amount of idle time. So enabling auto scaling, like if you don't want, like you can deselect it. Like in this case, there will be like by default 8 worker loads, but if you do enable, like let's say enable, so minimum will be 2, but if your workload is higher, it goes to the 8. And we have to like as so for worker and driver node, we have to separately like they're independent of each other. We can select which node we want, like what's our memory, how many cores we want. I'm not like changing it because it's a demo, but you can depending on your requirements. And you remember I was talking about the GPUs too. So here, like it's not a machine learning one, that's why you or like it's a standard one, that's why I can't select it. But you have like literally GPUs. If you want to do the deep learning kind of things, like you can have those nodes too. Same for the driver, you can have whatever you want. And the pool thing I was mentioning to you. So the pool, as I mentioned, like pools keep the idle nodes ready to use. So here we can like, I've created two pools like I already had. I'll show you how to create it, but like here you can select, okay, which pool you want. Like if you want your worker types to be coming out of the pool. So in that case, like, let's say if I do this, so for example, I'm just telling you like, we started our jobs or we're working on it. It's a standard. So let's say we have a job, it's working on it using 3 or 4 workers at the time, but like suddenly we got like a lot of data, or we processing a higher amount of data. So the other 4, like through the auto scaling, like we still have like 4 more to use, but they won't be readily available. Like it will take some time to spend the cluster. Even when you create the cluster for first time, like it take time. So selecting those, like selecting like a pool here, it reduce that time. So it's like basically saving your like your time. And this is for those critical situations where you can't like waste a minute, or like it's for those critical applications basically. Okay, I'm not going to create it, but this is how you create cluster, and there are like 3 different modes which we talked about. Okay, I talk about the notebook too, so let's go here. Okay, you can create a new notebook if you want. I already have one notebook, I'll show you. Okay, so it's a demo data set. So basically I'm using an open data source, the New York City, which we have used previously in other Seattle, New York yellow taxi data for Seattle. So this is an open data source available in the Azure data storage. So I'm using the same Azure blob account, containers, all this information I pulled from the Azure portal. I just want to show you, like if you work with Spark or you already have some experience from Azure Synapse Analytics, you will you will see like on the first two cells, we basically, in the first cell we are defining the token, what's our path, where is the file, what's the container, what's the account. So this is the open data storage, this is the container name, that's the path, and this is the SAS token for that open data sets in Azure blob storage. And after that we just connecting to it. Here we just like connecting it. After that, like once these 2 setups are done, like once you set up your connection or mounted your data lake, it's pretty straight, it's pretty simple. I won't say it's simple, but it's exactly same as Spark usage. You can see that we are reading the file of the Parquet file into data frame, then I'm printing it, and after that just displaying it. So if you understand Spark, like these 2 cells will be pretty easy. And these 2 also, like if you come from if you have seen my previous videos, this is like basically we connecting to a open data. And the other thing I want to talk about, these notebooks are pretty same as the Jupyter notebooks I was talking about. And here you can do like visualizations too. If you click on this, like this is a dummy visualization, but you can literally, let's do this. I'm just playing around, I don't know, but you can like change things and do stuff like so you can do the visualization also here. Okay, so here like you can, and the other thing is like as like Jupyter notebook, or not Jupyter notebook, like Azure Synapse Analytics, you can use your language. Like you can do different language, you can go SQL, you can go Python, you can go Scala using the using the magic command. Like for example, if I go here, like SQL, this will give you SQL or something, or like if you want Spark, something like that. Yeah, so you can switch your languages too. I started, like when I created this notebook, it shows Python, but you can change your language even even in the different cells. It's pretty same as like pretty standard as like notebooks. Okay, compute pool I was mentioning. So there's like these two pools. Like so far we haven't like attached anything, but like you can create a pool and let's say give it a name, demo pool 3. I'm just making, and then you can make like minimum idle, how many idle instances you want here, and then you pick like what kind of instance it is. Like you have to pick the configurations of your node, and same thing goes for the runtime. So here is the catch, like you keep the your runtime and instance pretty same as your cluster, or like the cluster one, you keep your cluster ones same as the pool. Okay, so that's how you create a pool, and we saw like how you can associate a pool. Like when you're creating a cluster, you just need to select a worker or driver node and pool existing pools. The job cluster. So here you can create a job. When you create a job, like you can see, you can create a new job cluster, or you can pick even existing all-purpose cluster. So new job cluster which will spend like when your job is running. Once the job is finished, it will be done. So let's say task. I'll create a demo task 2. Select a notebook. I go to users. Let's say hello world. This is a very simple one. I do hello world. If I want, as I mentioned, I can use this one. If I want, I can use this one. Create. So the task is created, like nothing is run so far, but because there is no schedule, if you click on schedule, do it this, and let's say it runs every month on 1st. I'm just making it, or you can show the ground syntax too if you want, but save it like so. Basically this job will run on 1st of every month at 3:23, and you can run it manually too, but like but here we have created a, like it's using a job cluster. It's not using any existing cluster. So when this job will run, this cluster will spin up. As this job is done, the cluster will die, and like the cluster will terminate. Okay, so anything else we're missing? Yeah, so that's pretty much for this video. So the main things on which I want you to focus is the understanding of like types of clusters and the pool, because in exam they ask about these things. Like, okay, they give you a scenario and ask, okay, which cluster need to be used, and this is like in the last 4 questions of case studies where they ask about these things. So thank you, and stay tuned for the next video.